So, hello and welcome to my next tutorial. Today I want to show you how you can use the GIS Map in Anylogic. In the end, I want to show you that agents are placed based on the GIS data defined in a database. And you can manipulate the data in the Anylogic database with changing an Excel file. So you have all your raw data of your locations saved in an Excel file. We transfer the data to the Anylogic database, and based on the GIS coordinates, the location of the agents are visualized on the GIS map. So for that, we need to switch to Anylogic. So let me switch to the screen. So what I'm doing is I generate a new model. Since I love numbers, I call it just model 16. It's finished. We have here a new model. And I immediately go to the palette space markup. I drag and drop the GIS map into my main agent with a double click. We can move the map. I'm going to Austria. I'm going to Upper Austria. So that's a little bit too far. Here is Hungary. Here is Austria. So we see here Upper Austria, Lower Austria. So I select this positioning. If you start now the simulation, then exactly this snapshot will be visualized in the main, but of course you're able to navigate as well in the applet. So if you start the applet, then we can see the GIS map is loading. It takes a bit time to make the internet connection, to take the material from the OpenStreetMap. And here is the selected area. So with the left mouse click, we can navigate in the map and we can zoom in a little bit more or out, whatever is needed. So the next step for us is that we search a single GIS point. So for instance, Steyr. So make sure that point is selected, then we search, and it takes a little bit of time, and then we have 13 items. I take the first one, which is not really specific, so it's Steyr in general in Upper Austria. I convert it to a GIS point by clicking on the right mouse button, and then we can see it turns to orange. Then I want to have an agent, so that means I go back to my project and I click on the model, right mouse button, I generate a new agent. The agent is called fish farm. I generate it from scratch. Next, I select the 2D visualization object. Then I take the blue house. Next, right now I don't need any parameters and I click finish. The agent opens. I don't need it now, so I close it. But what I do, here is the object and I take my first instance by dragging, dropping it into the model. It's called fish farm 1. Okay, now I have too many agents, so I delete one again. So for now, one is enough. And I want to visualize this agent on the location Steyr. So it's a single agent. So I click on it, then I observe the properties. It's a single agent and the initial location is in a node. So I change it in a node, and the node is what we have searched for is Steyr. So this is the GIS point. If I run the model, then we should see that the house is placed on Steyr. Very good. So that's what we wanted to have. Now it's very easy to take a second instance of my object, and that's located, for instance, what else can we take? Let's take a German city. Let's take Passau. We search it. Then we have 24 items. I take the first one. I convert it again to the GISpoint. And then I drag and drop a second agent into the model. So this is an instance of my agent fish farm. And I give a different location to it. So I change again to the node. And that should be Passau. Then we are in Passau. Then I run it. And what I do expect now is that we have two agents, one in Passau and one in Steyr. So here is Passau and one is Steyr. Good. Works, but is a little bit limited because it's more or less hard-coded. For the next thing, I deactivate those two instances. I just ignore them. And then I take a third instance into the model. And then I switch to the palette, to the agent palette, and then I drag and drop a collection. In this collection, I want to save all the GISpoints with which I want to work. So it's an array list, it's nice, and it's type others, and the object is a GISpoint. So control space, let's see what is found. So it's a GISpoint, and then I can add my two GISpoints, Passau and Steyr. If I go back to the agent, I have to configure it. Now it's a population of agents because now there can be 1, 2, 3 or multiple agents or GISpoints stored in this collection. So the initial number is given by the collection size. So control space, then I go for the collection, and it should be the size, which is 2. The agent location is given again in a node, and the node is defined in the GISpoint. The GISpoints are stored in the collection. So I go to the collection. Then I want to communicate with my individual agents. So I get to the position of the agents, and then I take the index. And if I run that now, I should have the same solution, but a little bit more smarter implemented. Because now I can immediately add a new agent, or I can delete one. So if I don't want to have an agent placed in Steyr, I delete it, I cross it out, then only one object, GIS object, is in the collection. I run the model, and then the outcome is only we have one agent in Passau located. So if you want to have more freedom, we can use data defined in a database. So we go back to the palette view. In the database, I click on the database, then you have the option to create a new table or import the table. So we do that. I import the table. I select here, it's an Excel file, and I open the Excel file. I have already, of course, an Excel file. I select this Excel file, and now you have the option to select the sheet which is in the Excel file. So let's have a look here to my project. So this is the raw data of my farms. So I have locations of different farms. So we can see here the ID number, the farms. So they're mainly located in Upper Austria. There are some abbreviations, and the location is mentioned here as well. Then the coordinates, the latitude and the longitude coordinates are defined for each single location. And then I have some attributes, the supplier. So I have 3 different suppliers. Then I have some values which are true, false, so that I can activate or deactivate some of the locations of the farms. And then how many properties are within such a location. Yeah? And that deviates between 1, 2, 3, 4, I guess. Yeah. So this is basically the raw data. So I don't save it. We go back to the Anylogic model, and then I can click on update data automatically on the startup, that is very convenient. If you change the data, add rows or delete rows, then immediately when you rerun the simulation or the experiment, the data is updated, and based on this Excel file, the simulation model is configured. So right now I don't need that. I click on finish, and then we can see we have imported the data. If I double click it, then we can see here all the data exactly as it has been shown in the Excel file. Automatically the type of data is selected. If there has been made some mistakes, then you are able to change it. You change it from integer to double. Please make sure if there is already data in the database, then it might not work. So it could be the case that you have to delete the data again, and then you can select the type. And here we also have again the option to update data on the model startup in case you have deactivated or activated it. Yeah, so right now I still have deactivated. And now we have to make the connection between the database, the Anylogic database, and our agent. So we need for that a new agent, a new instance. That's the 4th instance, the 4th option or the 3rd option what I want to show you. Again, it's a population of agents, and we want to load the agents from a database. Then I select the table of the database, which is indicated here in the sheet 1. So I select sheet 1. Then I have the option to distinguish between one agent per database or multiple agents per database. Yeah, so if we have a water farm, then we also have perhaps the amount of fishes living in this pond. Then it could make sense to replicate the amount of fishes based on multiple agents per record. So then I have St. Pölten. This is the location. There is a pond, and then I have 100 fishes, and then I can click on multiple agents. Then I can define the quantity and can perhaps select the amount. Yeah, I don't want to do that now, so one agent per database is enough. And then I have to do the mapping. Mapping means I want to transfer the data stored in the database to my agents. So if you have, or you perhaps have not seen it in the Excel file, but I have 63 locations defined in my Excel file. Those 63 locations are transferred to the database in Anylogic, and I want now that automatically 63 agents are displayed on my GIS map. So I transfer the data. Here, this is the data of the agent. I have here the GIS location, the latitude, and we have it the latitude stored as well in the Excel file. So, or in the database. So if we recall the data, we have here for the location alt time, the latitude and the longitude stored. And that's what I'm doing now, is I transfer the attribute location is imported from my Excel file, which is stored in the database in the column latitude. Same option is done for the longitude. and the longitude is here. If I run that, then let's see what is happening. I expect now 63 blue houses. Welcome, so please feel free to count them on the locations which have been defined in my Excel file, which is already very convenient. Yeah? The next step is, this is a very stupid agent. Right now I'm using the agent only for visualization objects, so that means I have only a blue house. Yeah? So if I double click it, then my agent should open the fish farm, and here we just have this visualization object. Yeah, it's very boring. But I can give some configuration parameters as well to this agent. So a capacity, yeah? So a volume, amount of fishes living in the pond, or a growth rate. Yeah? So these are all parameters which are needed to specify or configure the agent. So that means I generate here a parameter, and this is the attribute size. Writing is not that easy. Size. So that means that I want to have for all 63 locations the corresponding size, and this size is stored in my database. Yeah? So I called it here. Is it? Here is the amount. So this is the amount, and that should be transferred to my agent. So I go back to the main. What I'm interested is now in the mapping. Yeah? So we can see that I have now a new option here. So the attribute size, what I have generated now for my agent, and then map it with the amount. If I run it, then we can see, if we go now to my fish farm 3, that we have transferred the size for the first agent is set to 2. For the second agent, it's 1. For the third agent is 4. So 214. And what is stored in the database is 214. And you can go all down the way to the 63rd item. So I start with 0. So indeed we have 63 location stored here. So, and now you can do, so the visualization is done, and you can also have access to all the agents. So the idea is that you define the structure in the Excel file, is loaded in the database, and based on this database, the simulation model is configured. Then you have the basic structure, then you can execute the simulation model, and in the end, you want to have some key performance indicators. And perhaps you want to bring that back in the main. So that's very easy, since I don't have logic implemented. So that's based on your model, what is needed. I make a very simple model. I drag and drop here a variable. I call that KPI farm individual. So after a few seconds, to be more precise, I select 1 second. So this event occurs once after a second, and it should store in the variable KPI farm individual a random number. Yeah, so I use uniform distribution between, let's say, 1 and 10. Yes. So expect that values between 1 and 10 are stored in this KPI. So if I run it, Java applet is generated after a second. So that should be done immediately. So model is running. I see we are already in second 5, 6, 7. I select my fish farm. So we have a KPI of 7.993 for the first one, for the second one 7.515, 9.28, and so on. So I have now already my KPIs. And now I want to have access in the main. So I just put here 2 parameters. I mean, you can also use variables, but if you want to use my Excel connection, which you also find on the YouTube channel, then you need, you don't need, you can also use variables. Yeah? So we can use a variable. So we delete it, then we take a variable. So this is KPI farm 1. Then we copy that. This is KPI farm 2. I just do it for 2 farms. And then I take an event. In that case, I take 2 seconds so that all KPIs are calculated. Then I want to have in the KPI farm 1 the value from my KPI, which is stored in the agent. Yeah. So this is, I talk to my agent, fish farm 3. I have to select to which agent I'm talking. So I get to the first agent, so get 0, the first agent. And if I press Ctrl space, then we can see here is my attribute of the size. And I have here my KPI farm, which I'm interested in. So then I copy that. And I select here the second agent. And if you run that, and hopefully I made no mistakes. No mistakes are so far available. And we can jump to the agents, fish farm 3. The first agent has 7.993 to remember that, and the second was 7.5. So if you jump back to the main, here are 7.993 and 7.514. So what you can do is you can now loop with a for loop over all agents stored here in this population, and then you can calculate the sum, the average, whatever is needed to have your key performance indicator. You also can use graphs, the XY diagrams, so there is a lot possible. Thank you so much for watching this tutorial. Good luck with your modeling. All the best.